Hi guys, welcome to my amateur YouTube channel where today I'll be explaining an idea I had for optimizing an electric motor. So let's jump right in. Okay, so this is the basic structure of a DC electric motor. I expect you to understand how this works to understand the next part. Okay, the idea is to have multiple magnetic fields to increase the torque of the DC motor. So usually we have a magnetic field where we have north, we have south, we have an armature connected to a DC power source, like so. Alright, so what I'm trying to do, or what I propose someone should do, is to add more magnetic fields. Like maybe we can have another magnetic field here, north, south. Okay, let's add some field lines, north, south, and then another field here, north, south. I'm sure you already know that this will cause some complications because, as you know, as the magnets, the electrons travel in this direction, the Lorentz force would cause the armature to rotate. That means the force would actually be out of the page. At this point right here, it will be out of the page, and here it will be into the page, right? But as the electrons travel to the other side of the armature, that means the field lines will have to travel in this direction. But then this field here would cause complications. So how do we solve that? This is what I propose. Okay, so this is what I think would work. So let's have right here, let's have multiple field lines arranged in a certain manner. What I mean is, let's have this arrangement right here. Excuse my drawing. Right, so these are the field lines. You can fast forward this video to a point where you think this video will be less tedious and annoying to watch. Okay, seriously, I just fast forward the video because this audio is also tedious for me. Great, so what I mean is all these will be north, 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 north. Because normally, optimally, the field lines have to go this direction on this side of the armature. So we can have the Lorentz force, right? And in order for the motor to keep working, the field lines on the other side of the armature have to go this way, right? North, south, north, south, north, south, north, south, etc. So all these are magnets, all of them. They're all magnets. But because the field has to go in this direction for the armature to rotate, so you have the Lorentz force, we need all these magnets. So we can arrange them in a manner that the field will go in this direction. Because if we have this arrangement right here, if we have these magnets, these field lines, this field will cause the complications because it would cause the armature to rotate in the other direction, and we don't want that. So now, excuse me, with this one, the field is constantly going in that direction. So you can have your armature right here. your power source, DC power source. So this is how it would work. But then actually, no, actually, that's a mistake. The ammeter has to go through. It has to go through these magnets. Yeah, excuse this part here. This is wrong. And I'm not gonna redo this video because I hate recording. Sorry. Right. This is the armature. It will go in between the magnets. South, 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 south. Right. So in this part, the electron will travel here, and it will be in the influence of this field right here. Right. But then as it rotates, there's another electron in this part. It also experiences the Lorentz force into the page, out of the page, right? So we have torque. We torque like that. So right now we have multiple magnetic fields constantly creating a Lorentz force in the electron at every path in the armature, right? So that's the idea. That's the optimization. What I mean is, if you have multiple magnetic fields and if they are strong enough, then you should maximize the torque of the electric motor. Just tell me what you think in the comment section. And feel free to dislike this video because the quality sucks. Thanks.